We got 11 here. Still missing a few. We're not going to wait very long to get started because we got to get through our lesson today, and we've only got 45 minutes because our new schedule started. Anyway, welcome. We're going to start looking at actual programming now this week and going forward. So I'm not going to take a whole lot of time wasted. Let's jump in there. We want to look at the good stuff. Let's put it up on the screen and start looking at what we have. So going to Buzz, we have our Foundations of Programming course right here. 0A. Here is that first module. Then we looked at this a little bit last week. We've already done the academic integrity contract. You've done that. Let's have serial assignment. At least I hope you have. I haven't looked this morning to see if everybody got that done, but hopefully you've got that done now. There was like 4 of you missing that on Friday, but it wasn't due until like 8 hours ago. So 8 hours ago it was due. So hopefully you got it done. But here's how I want to show you to look each week. When you log in, go to the grade screen. Here's a little shortcut, or you could also go to the menu and go to the grade screen. Either way, we go to the grade screen. Oh, I don't have it showing what the due date is. It will normally have the due date. I don't have it showing that. I'll change the settings so it shows that. But what we're doing this week is lesson 1.01, Intro to Programming. I may have saw that in our. I'll put this up on the screen real quick. If you go to the classwork tab, this is week 3. When you go there, oh, it doesn't have it on there either. Man, Mr. Brock, you were in such a hurry you didn't get in there. I will get it fixed. But what we have this week is lesson 1, Intro to Programming. So let's go to that lesson. We have the lesson, then the assignment. Intro to Programming lesson. All right, every day, programmers write millions of lines of code. Programmers is defined as a person who writes instructions for a computer, and code is defined as instructions in a computer program. So to an outsider, it might look like a bunch of jumble of letters, numbers, symbols, but to a programmer, code looks like a way to change the world, right? For programmers, the responsibility is pretty huge, but the payoff is amazing. Like if you have the power to change the world, then you get to decide what the future is going to be like. So we're going to learn in this lesson the role of a computer programmer. We're going to describe different career opportunities, identify how businesses people use programming, and describe how programming has evolved. But don't worry, we're going to be doing some programming real quick in this class. Are you ready to code? Let's cut to the chase because you really just want to start writing code. All right, hang on. But first, you need to learn important information about why you're coding and how the programming world has changed. Okay, let's have a quick sneak peek into programming. Throughout this course, you'll use an interactive tool called Python Guided Activity. That's what in these lessons, you'll see these Python Guided Activity. That's the name of it right there. This is your Python coding environment that will give you the chance to practice programming by writing and editing. And you'll be able to test your knowledge as you learn how to write programs, which is a set of instructions written for a computer to execute. All right, so let's take a sneak peek at what programming looks like. So over on the right, it says programming sneak peek, read the code, try to predict the output, and then select run. All right. So let's read the code. First thing we see is this, there's a hashtag, age calculator, how old are you? Now I'll tell you in Python, if we put this hashtag first, this number sign, that tells Python, this is a comment, you can just skip this. That's for people to read, not the computer. The computer doesn't even read that line because we put that hashtag. So anytime you need to put a comment or somewhere where you're explaining some line of code or doing something, you just put hashtag and the computer will skip it, and that's something people read. So we have this DEF main, parentheses, colon. This is saying I'm defining my main function. So, hey, computer, this is the main part of the code. This is the main part of it. And now we've got birth year equals 2000. Birth year, notice it's all one word. There's no spaces. This is a variable. Think of it in math like this is X equals 2000. But we're calling it birth year because if we just said X equals 2000, and if we have a program that's 100 lines long and we get down to line 98 and we reference X, We're like, what was X again? That doesn't make it. We can't remember what X is. Birth year. Oh yeah, that's the they entered the year they're born. Birth year. So we don't use like X and Y as variables. We use words, and don't put any spaces, because then Python will think it's two different commands, two different things. We put them together as one word. And like when there's more than one word there, you capitalize the second word. So birth year. So that makes it easier to read. So this is a variable, like X equals 2000, but we call it birth year. Current year equals 2016. This is also a variable. Now we have a calculation. Here's another variable called age. This could be X, Y, and Z, right? So age equals INT current year minus INT birth year. For Python, INT means integer. This is a number. This is not a decimal. This is not a fraction. This is an integer. You know, we learn in math, integers are numbers, right? Not decimals. So we have a variable called age, and age is equal to the current year minus the birth year. And then, oh, here's a print statement. So that means it's going to actually print something to our screen. It says, this year you will be STR age years old. Now we'll talk about this STR thing when we get a little farther, but let's run. And then main right here. So what this is doing is defining the main function. It's telling the computer, this is the main function. And after we write it, we go down here and say, okay, now run the main function. Now go do that. That was the main function. Now go do it. So this has to be at the end of our program. That's the end of our program to tell it to go up and run this. So let's hit run program. It says this year you'll be 16 years old. That's the only thing we see, because that's the only print statement. This is the stuff that it calculated, and then it printed you'll be 16 years old, because this year you will be, see, this year you will be, this right here is age, which we calculated on the line above. And then it prints space years old, exclamation mark, space years old, exclamation mark. Pretty cool. It says, why don't you play with the code and change the birth and current years? Okay, now the current year is 2025. And let's say you're born in 2009. Oh, because it's going to be the same answer. 2008. You'll be 17 years old. Let's say that you're Mr. Brock and you were born in 1967. 58 years old. So yeah, you can change these numbers, and this is available for you. This is in Buzz. You can go and play with this and see what you can do. All right, there's two different sample programs here. So when you see this at the bottom, slide 1 of 2, we need to hit next and look at the other one. Age calculator, how old are you? So this hasn't changed. That's still a comment. Define main. Oh, now the birth year is not defined anymore as 2000 or 2008 or whatever year we put in there. Now there's a statement that says input. And here's a phrase that says, what year were you born? Current year, input. What is the current year? And then this is the same thing. This is the same statement it was before. Age equals the current year minus the birth year. And this is the same. This year you will be age years old. So it says, when asked, enter numbers for the year. So let's run the program. When we see input, that means when someone runs my program, it's going to ask their input. Look, it popped up this window on the screen when I hit run. And it says, what year were you born? That's what that line says right there. Input, what year were you born? Oh, well, I was born in 1967. Okay, now it says, what is the current year? Because that's what the second input statement said. It is 2025. It says this year you'll be 58 years old. So you can go play with this. Say, amazing, you're already learning about coding here. Learn how to code. Don't worry if this is still confusing. We're just getting started. But yeah, you can enter whatever. What year were you born? 2010. What year is this? How old am I going to be in the year 2060? 50 years old. All right, let's go to the next page. Notice there's 7 pages here. We're about to go to page 3. Well, there it goes. It's like I thought it was going to page 3. Who are programmers? Can you read this? All right, somebody read that for me. No, I don't want you to say 0, 1, 1. Tell me what the words are. It's like, what? Yeah, this is what the computer actually reads. It's binary. It's binary, which means these are all a power of 2. Like if we just look at this right here, this is 2 to the 0 power, so there's nothing there. 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth power, 2 to the fifth power, and we can look at that, and that's a number or a binary. Here, let's see how the computer would read this, all this binary code. That's binary for I am awesome. That's what this says. I am awesome. But it says it in computer speak. Computer reads binary. So binary code is a code language. It's all zeros and ones. But don't worry if you're not fluent in binary. Computer programmers write code that translates commands to binary. So Python will take all the commands we've got and it'll convert it into binary and send it to the computer so the computer knows what in the world to do with it. You translate commands to binary code so computers can understand them. So what else do they do? Well, I'm glad you asked. By the way, commands, instructions given to a computer. So here are some things you might not know about computer programmers. They're inventors, right? When you write a program, you're inventing something new for a computer to do. Programmers create programs that solve problems, sometimes from scratch, sometimes from existing code. You may take an existing program and improve it and make it do more. Or you may start from nothing and build the whole thing. Their creations help power every industry in the world. They're fluent. There are thousands of programming languages. Don't worry, we're just learning one. So each one has a different set of rules and is meant for a different purpose. A programmer might specialize in one language, but it's likely he or she is fluent in a few for good measure. So people that work out there usually know a few different languages, but usually are best at one. They're visionaries. They don't just write one program and move on. A programmer's vision for a program includes bringing it to life and then finding ways for it to expand and evolve it to new, better programs. I mean, think about these games you play on your phone and stuff. Those are programs that are written by a programmer. And they started out just doing whatever the game did when you started. And then they start adding more stuff and the game gets more complicated because they keep adding to the program and they're making it evolve and become bigger and better and there's more you can do. Right? So they're gatekeepers also. Writing and owning a program involves testing your program first. I need to make sure it writes before I let you use it. Debugging it, that means finding and fixing the errors. And we'll talk about why they call them bugs. And resolving any issues to make sure it's working for the end user. And they're also researchers. Code libraries. There's libraries of code. Programming threads, collections of best practices or resources that programmers constantly seek out to improve their skills and share ideas. But let's look at page 4. Can I be a computer programmer? You bet. Everyone can. They can be men, women, old, young, any part of the world, people from all walks of life. Here's a couple of programmers you may not have known about. Lindsay Scott can be known on the runway. She's a model, but before she became a model, she learned to code. How did she do that? She started by creating games on her TI-89 graphing calculator in middle school. She started creating games on her calculator. Today, in addition to having a successful modeling career, she's created several mobile apps. So this lady that walks the runway as a model also creates apps. NBA All-Star Chris Bosh, who's retired now, but he's an NBA. He's known for his three-pointers and his rebounds, but even before basketball, the player with the number 1 in his jersey had another interest. He wrote programs. He knows how to code, right? Who was the first president to write code? Oh, a trivia question. Who's the first president to write code? And don't say George Washington because there was no coding back then. President Obama was the first president that actually wrote code. So he's familiar with that. Teen programmers. In fact, some of the most innovative computer programmers today are teens who are using code to jumpstart their careers and change the world. So let's look at this slideshow to see a few of them. Here's Trisha Prabhu. She's an 8th grader in Naperville, Illinois. She programmed the Rethink Alert. I don't know if any of you have used this program, but this combats cyberbullying by alerting people that their posts on social media may be offensive. So if you had this installed on your computer and you go on your phone or wherever you got it installed on your phone and you go to write some text, if it sees something that it might be offensive, maybe you're saying something rude about someone, it stops it and says, hey, you need to rethink. Is this really what you want to post? So it gives people time to rethink and revise. So that's how she wrote a program to help combat cyberbullying and to let people go, wait a minute, yeah, maybe I don't need to say it that way because it's going to be taken wrong, or I don't really want to make someone really mad. I should rethink it. So she wrote the Rethink program. Here's this fella here at age 12. Michael Saman learned to code at age 12. By 17, he created Four Snaps, which is a multi-user photo game that took off in the App Store. Facebook took notice and offered him an internship, and now he works for Facebook as a software engineer. Software is programs written for computers. But he started coding at age 12, and at 17, he had this big game, making a lot of money. At age 18, Brittany Winger, a native of Sarasota, Florida, had built a breast cancer diagnosis program that could change the face of medicine. Inspired by a diagnosis in her family, she researched the program and tested a diagnosis program that was able to detect 99% of life-threatening tumors. And in 2012, she won the Google Science Fair with it. Which brings me to our current story over at Bentonville West. We have a couple of fellas that built a program last year to detect mouth cancer. They have a little like 3D printed adapting thing you put on your phone, on your camera, and we put it and it holds your mouth a certain way and takes a picture. And then their program on the phone analyzes those pictures and is like 99% more accurate that, yes, you need to have this spot looked at. It looks like mouth cancer, or, hey, it looks pretty clear. And it's more accurate than a lot of the experts that actually look in there. And they won all kinds of stuff. They won in the state. They went to national. I think they finished in the top. They won the, was it Google's award last year, the Google Science Fair? Or Samsung. They won the National Samsung Award for that. Got a big scholarships and all this. Some kids from West writing some Python code. Wrote this app. I may not have been Python. That may have been a Java code, but programming in high school, winning big scholarships right here. So you can do that. Let's see. Let's go to page 4. Oh, that is page 4. Page 5. What do programmers do? Well, the short answer is programmers write code that tells computers what commands to follow. In essence, they solve problems with their code. So the important details here. Back in the day, programmers used code to perform calculations, and they did all that manually. Code ran on these huge machines. I mean, yeah, computers used to be huge machines that turned gears by hand. You'd go and to program, you'd have to redo this machine. You got to switch this, put the switch there, turn this gear, attach this wire to connect these two components. Programs could take days or weeks to totally run because you got to do each section of the program by moving things on the actual machine. Well, today getting code to run is a lot easier. Well, at least physically. But the things that programmers can accomplish have gone far beyond just basic calculations. These modern day superheroes not only give us the ability to Snapchat, because some programmers wrote that program at will, but they're also present in every industry that exists today. You name it, they'll code it. Like if you've ever watched a video on YouTube, YouTube runs on Python. Python kind of manages YouTube and their algorithms and the views and all that kind of stuff. Lots of different things. NASA uses Python. Another task programmers perform is writing software. Programs written for computers to perform specific tasks. The term we use to describe the interface allows communication between humans and computers. So that's the term we use to interface between you and the computer, is software. Remember the last time you had to write an essay by hand? No, you probably don't. You didn't get a pencil and paper and write an essay. You went to Word or some other kind of Google Doc and you typed it. You can thank a programmer because they created that program to where you could just type it and it would save it onto a document for you. Software is your go-between. Your program is created. Think about this. Programmers actually write new software with existing software. You use software to write software. Because of this, programmers have one of the most powerful jobs in the world. So what can programmers do? Let's look at some things here. Healthcare. Computer programming has revolutionized the healthcare industry. Like I was just talking about this app these guys created in Bentonville West over there that you can help look for oral cancer. Makes it more powerful and efficient than ever. Patient portals, robotic surgery, 3D printed prosthetics. None of these would be possible without programmers. Education. The education industry depends on cutting edge software, helps students stay at the front of today's technology. In fact, a programmer wrote your online class. A programmer wrote this software to be able to let us meet through the internet, that where we all show up with our little pictures on the screen, and that we do all because some programmer wrote Google Meets. Military. Computer technology has easily become one of the most powerful tools in the military. Oh my goodness. Yeah. They rely on programmers to develop drones, maintain operational security, develop cutting edge technology. The military has a lot of programmers, guys, a lot. Technology. The tech world's made up of programmers who make tomorrow's technology possible. From building social media sites to building talking smart cars, programmers are changing how we experience the world. Entertainment. Films, video games, concerts, and more all use programs to create the effects we enjoy. Yeah, almost every movie these days has some kind of computer application built into it to make it look different or right. Agriculture, if you think, like even be the farmer now, agriculture's come a long way from the days of early planting. Now software created by programmers helps us track and plan growth so we can have the healthy food we need. Can keep track of a lot of the farming that we're doing as a country. Construction, architectural industry makes heavy use of programmers who have amazing new accomplishments in building and construction. Programmers write code to mock up buildings, map out land, and more. Yeah, they'll on the computer, they can build what the buildings will look like, and they can see if there's any design flaws or something and see if it's going to work before they actually go out and buy a bunch of stuff and hire people to build it. Adaptive technology. So people with disabilities rely on programmers to create software to overcome daily obstacles. Screen magnifiers, touchscreen displays, speech recognition software is among the many other features which allow people to perform daily activities better. So like even closed captioning on your phone, people that are deaf have phones that when you call them, whatever you say is printed out on a screen for them so they know what you said. And then they can speak back, or if they can't speak, they can type and it'll send it back and transfer it back to words. Lots of stuff that can help people. So where did programming come from? Well, it's probably a lot older than you imagine. So let's look at the timeline below to see. So today, gaming, hacking, developing code are part of our everyday world, right? Everyone around you is either building or interacting with some kind of program on a daily basis. Like, look at all this over here. There's a program. Here's people using a program there to monitor their heartbeat and all that kind of stuff. What it looks like. Programmers today work in every industry imaginable. There are thousands of different programming languages today, all developed to meet different needs. Mobile devices, constant need to access information. That means a higher demand for smarter and more complex programs. So that's today. Let's go back to 1981. MS-DOS was released. MS-DOS. This allowed people around the world to use the early operating system for their personal computers. So that's personal computers started moving into people's houses in the 80s. Windows hadn't been created yet, so nobody had a mouse. You didn't have a mouse because there wasn't any way for mouse they have to write code in order for a mouse to actually do anything. You had to type commands. There was no folder icons. There wasn't anything to click on. It was just a blank screen that you typed words on. Pulling up files on a PC in the 1980s meant typing in commands to direct the computer to correct locations. I had a very early computer that actually hooked up to my TV. It didn't have a monitor. You could just like a game system, but it was a little keyboard and computer built into it. And I could type commands on it and make it do something on the screen. But if I wanted to save my program, get this, if I wanted to save a program, I had to plug in a cassette recorder, hit record on the cassette, and then tell the computer to save it. And it would save it as sounds. Beep, 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 boop, 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 boop. And then to reload it, I got to tell the computer to load, and I have to rewind the cassette and hit play. And as it played, just like you're playing music on a cassette, as you played, it would load the computer program back in the computer. It was crazy. Now we just hit save, and there's a hard drive built into your computer, or it's saved on the cloud somewhere, and it's very, very different. The era of the personal computer, because before this, computers used to be the size of rooms and only businesses had them. It brought programming into the commercial world. Programs were written so end users could type simple commands to open, close, and run applications. Before that, you had to know all the code to make something happen. A computer programmer's job expanded from developing specialized programs for specific purposes to building software for everyone users. I mean, I'm very happy someone wrote Python. Someone's built all the code for Python to work. Let's go back to the 60s, 1968, 69. Nicholas Wirth designed the famous programming language Pascal. He was in his 30s when he built it. The development of Pascal pushed programming into a new era, past general calculations and into a more sophisticated and structured approach. What it looked like as programming became more sophisticated, demand for programmers increased. More languages meant more opportunities for programmers to create new technology. Let's go back to 1957. Look at these cards, Fortran statement. John Backus developed the first programming language at IBM that's still in use today, which is Fortran. Fortran. And look, this was actually a card, a printed out card, and it would punch holes in the card. And so to run the program, you have a whole stack of these cards, and you got to feed them in the right order to load your program into the computer. I actually dealt with some of these in high school because my computer teacher had an old system that used these Fortran cards, and I learned how to do that. The language has evolved now, Fortran, to perform highly advanced calculations. It's fast and effective at completing tasks. As computers got more advanced, so did programming. Programmers developed new languages so they could translate commands into binary, so machine code, so computers can understand. Because computers just use binary. So this is putting zeros and ones into there. Let's go back to 1946, right after World War II. The Electronic Numerical Integrator and Computer, they called it ENIAC, which was developed for the military, was the first electric general purpose computer. And look at the size of it. See, there's a guy standing there using the computer, plugging some wires in. It had over 17,000 vacuum tubes. It looked like a light bulb, but they're tubes that they screw in, and it created vacuums in there, and that's how the computer ran. Its creators nicknamed the ENIAC the giant brain. And that room would get really, really hot because all those vacuum tubes produced a lot of heat too. So what it looked like early on, a programmer's job involved physically turning gears, flipping switches, attaching wires on these huge machines for every task. Or think of it, for every line of code, you'd have to flip all these switches and change all this gear just through that one line. And now the next line of code, we got to do all this again. It was labor intensive and prone to errors. Because if you do it out of order, you got to start over. And maybe you've been doing it for 3 days. But now, oh, wait, I turned the wrong gear. Now let's jump back 100 years to the 1840s. 1842. Ada Lovelace, the daughter of Lord Byron, for you folks that are familiar in the English literary world. Ada Lovelace wrote the first computer program in 1842. She was dubbed the Enchantress of Numbers by Charles Babbage, who was the inventor of the first computer. She's known as the world's first computer programmer. Now, of course, she didn't do anything on a machine, nothing like that. This is something she wrote on paper. But when they looked at this later, they said, really, this is the layout of a computer program. In the beginning, programming mostly existed on paper. We didn't have the technology to do that, but we had an idea of the logical steps that it would take to do something. So the reality of programming was realized when Ada wrote an algorithm to compute numbers, a set of precise logical instructions used to solve a program. So that's what she did. She created this algorithm in order to solve some math problems. If you just follow those steps, it would do it. Well, that's what a calculator would do today, or a computer program would follow steps to produce something. So she is credited with being the very, very first computer programmer. Wrote the very first program, even though it was 100 years really before there was computers to run anything on. So programming has come a long way throughout the years. Well, it used to be something only a handful of people dabbled in. Today, it's one of the most in-demand skills for many careers. A computer's processing ability far exceeds any human brain, but without a human programmer input and our desire to solve problems, the computer is really just a pile of metal and plastic these days. So here's our programming spotlight for the week. Ada Lovelace. She lived from 1815 to 1852. Yeah, she was only 37 when she died. We're dubbing her Most Intelligent. She's known as the first computer programmer in history. She wins the award for Most Intelligent. She wrote an algorithm that would compute Bernoulli numbers. This is a sequence of signed rational numbers that can be defined by the exponential generated function. If you want to get into the math of it, that's a whole different class. But she did an algorithm to find these numbers before computers even existed. And her early work provided the foundation for computer programming. Fun fact, as the daughter of the famous poet, Lord Byron, she was encouraged to study math because Lord Byron went insane. Her mother feared that she would inherit his passion for words, which is why they believe he went crazy. He had such a passion for words, it drove him insane. So she told her daughter, you need to study math. Don't study literary stuff. Stay away from all the English and poems. Study math so you won't go nuts like your father did. Okay, that's probably not why he went insane. But anyway, that got her into the world of math and really moved her along. So, all right. Last page, it just says, read the lesson, practice using Python, complete the quiz. So our assignment for the week is right underneath it. This is the Intro to Programming lesson. This is the Intro to Programming assignment. And if you click on this, we have 5 multiple choice questions. And it's all about the lesson we just read. So look at this. If you don't know the answer, you can always save and exit, go back and look at the lesson again and come back. You don't, it's not like you have to answer all 5 at one time. If there's one of these you don't know, you hit save and exit down there and it will save the answers you've turned in, and you can always go back and look at the lesson again. And if you don't do well, you can retake the quiz as well. So I think it may let you do 3 attempts. This has 1 attempt. I'll change that. I'll make it 3 attempts. Right now, just let you do it once, but I will fix that as well. So, all right, that's where we have an easy start. I do want to put this up on the screen because I got this. Let me go back. Let me go back to this real quick. The place that we're going to program at is this on the menu in our lesson is this idle button. When you click on that, it actually opens up a programming window. And this is a Python window. So when we type code right here, hashtag, here is where our code goes. When I run it, nothing happens because I didn't tell it to do anything. That's just a comment. It's right here. There are other places on the internet you can find places to write Python code. But here's what I want to emphasize. Screen. When working on assignments for this course, use the built-in idle. Again, that's what I clicked, idle right there. That opens this window. Use this. If you use a different idle for your assignments, beware. Different idles or different integrated Python windows somewhere may run different versions of Python. And the code may or may not work when you come back and put it in our course. So for best results, may run different. Use the idle build in this course. If you build a Python program somewhere else, then you need to come back here and test it to see if it works here before you turn it in. If you hit save, it saves a little. I don't know where it saves it. You got to look, see where it saves it. You can always copy and paste it too. But this is where our programming code goes. Idle right there. All right, guys, questions. We're just starting out with our first look at what does a computer program look like? How did it get started? We kind of looked at the history of computers, which is kind of cool to know. Wow, it really goes back a long ways farther than you might think. 1842, our first program. But yeah, we're glad computers aren't the size of this classroom now, and then I'm not having to turn gears and everything to make a computer run. I just hit a button and things happen. So. All right, guys, if you don't have any questions, I'll let you get started on this. You got your assignment. I'll give you a few minutes to work on that, and I will see you. Let's see. If you got everything turned in, then you've got 100% because I was grading on completion last week. If you didn't do last week's, then I guess I'll see you Let's see. Friday is an A day. So we have class Wednesday and Friday, but you don't have to be here as long as your grade's over 70%, right? You don't have to be here. So make sure everything's turned in. You'll do a grade check tomorrow in your advisory class. And if your grade's 0, if you haven't turned anything in, I'll see you twice more this week. Otherwise, I won't see you again until next week, guys. And next week is Monday is a holiday. Monday's Labor Day. We don't have any school. So our class will meet on Wednesday next week because that'll be the first A day. So we'll meet on, everybody has to be here on Wednesday next week because nobody has to be here on Monday. Got that? That kind of makes sense. All right. Well, have a great week then, unless I'll see you Wednesday and Friday. But if you haven't turned in last week's stuff that was due 8.5 hours ago, turn it in now. Hurry up, get it in because I haven't looked at it yet. I'm going to grade anything that's turned in. Doesn't take just 2 minutes. All right. Have a great week.